I'm Kevin and we're in an injection molding department here at Harken where we're going to discuss these pellets and how we turn them into finished parts. Most of the raw materials we use in this process are nylons containing glass fill. One that does not, we have a xenoid compound, we have two different Delrins, a Celcon and then a red colored Delrin. Engineering determines what material we're going to use for which part. Some may need something that's a little bit more tougher, while others might need something that flows a lot easier or has a little bit more of a resistance to friction. First, our materials start out in the dryer, where these dryers are specific for each material we use. And what it does is it takes the moisture out of the pellets. That way when the pellets come to the press, there's no moisture in it, doesn't cause any steam. All of our machines have loading hose that are hooked up below. As the pellets funnel through, the hoses on the machine will call for material and it gets loaded up from there. The loader on each machine will call for the plastic. There's a sensor on it which will dictate how much it needs, and once it gets below a certain point, it'll actually start loading up more from the dryers. From there, it'll actually get fed in through the screw, which is like an auger. The barrel temps are, for this material, are set close to 400 degrees. Each material, though, has a different range point of melting. Some are higher as far as 570 degrees, all the way down to 350 degrees. So what happens once it reaches the screw is that the screw will rotate, which will compress the plastic. And this is what's called plasticizing. This is actually where the plastic actually starts to get its gooey melt stage and where it gets most of the heat from. The barrel heats start to loosen the plastic up, but once the screw actually rotates, that friction is what causes the plastic to actually melt from there. It'll inject the molten plastic into the cavities of the mold, then go through a series of holding pressure and then cooling time before it'll open up and it'll drop out the part.
Hi, I'm Jordan, and we're here in the tooling area to talk to you about the molds that we do at Harken. Well, first, we would get raw material, machine the raw material, we'd have a finished block. This is carbon or an electrode. We cut the carbon electrode to actually burn it into the steel for something that we can't normally do in a milling machine. So with the EDM, it uses electricity and it actually burns it into the steel. There's multiple different steps and multiple different electrodes to burn each cavity. And once we sink or EDM it, it would turn out to a product something like this. And then we'd be able to fit it into the die set. And once the molds are complete, we bring it over to Kevin for him to try out.
So the cycle time will vary from each part depending on the design. This one actually is 35.1 seconds. It has another 11 hours and 12 minutes to go. So in 11 hours, we'll have 1,500 parts and that'll complete the order. So here's the 57 carbo shiv. Once this goes into assembly, they'll assemble it. And here's one of the other parts that it'll assemble with, which is the 57 carbo fiddle.